Thank you. That was actually okay. We're going to do, what are there? Let me just throw this around here. 1, 2, 3, 4. There's 6 problems. We're going to do the first 4 by hand because it's healthy for you to remember how to do antiderivatives. And then the last 2, I'll have you pull up Desmos and we'll practice using our calculator because that's also a good skill to have. So these are volumes of revolution. I love talking about that because I'm always like, revolution. It means you take a shape and you spin it, revolve it around an axis of rotation, which is oftentimes the X or the Y axis, but sometimes it's not. Sometimes you move it around and you create this 3-dimensional item. Do you remember how last time I said you have to have an imagination and imagine shapes popping up out of the paper at you? You're going to have an imagination and imagine a 3-dimensional object, okay? Now, if you have a horizontal axis of revolution, like the x-axis, all right, horizontal, it could be the x-axis or just horizontal like the x-axis, then that is dx. If you have a vertical axis of revolution, it could be the y-axis or just vertical like the y-axis. That is a dy problem, okay? So let's go ahead and draw the first one. Find the volume, so 3D here. And I think one of you asked about units. They typically don't give units for these. But for the sake of being thorough, what would be like a unit for a volume? Something cubed, so like cubic inches or cubic feet or something. But again, they don't have them, so we don't make them up. Just don't put anything. All right, we're going to revolve the plane region. That means flat, all right? Bounded by, all right, y equals square root of x. We can put 0, 0. We can put 1, 1. And we can put 4, 2. For the sake of being thorough, what would the next point be in order? 9, 3. Oh, and before I draw it, if you're writing with pencil, cool. If you're writing with pen, wait until I'm done because we're going to erase some of this, okay? All right? So if you're writing with pen, don't do this. Wait until we're all done. If you're writing with pencil, you can do it, but we're going to erase a little bit. All right, the x-axis, so that's this right here, the x-axis. And the line x equals 4. So it's a vertical line at 4. So this is the shape that we get. And what you want to erase are what I call the tails. Everything that's outside of that shape, you want to erase so that we can use our imaginations better when we go to spin it or, revolution. Okay, so we're going to take this shape right here. And we're going to revolve it or spin it around what? What does it say to spin around? Okay, so I know it's going to be a dx problem if you want to make yourself a note, a little margin note to yourself. So we're going to draw what I call the ghost shape, okay? You're going to draw a ghost shape reflected over your axis of revolution. So down here, and you have to imagine it. You have to use your imagination. You have to imagine this shape spinning around and creating a 3-dimensional object. So I always like to take a brief moment and think about what that would look like. If you turn it this way, it would look kind of like a cereal bowl that you could not put any cereal inside of because it's solid the whole way through. Do you get what I'm saying? Or like a spinny top, I guess, like a dreidel sort of thing. Do you get what I'm saying? But do you understand that it would be like this? It's 3-dimensional. Okay, let's make sure we understand what's going on. Now, because it's 3-dimensional and you go around in a circle, all of your cross sections are circles. Do you see how these are pi r squared? All of these pi r squared? Set it up blank, pi r squared. Here's what we're going to do. Pi blank squared dx. Set it up blank. If you miss the pi, you're going to lose a point. If you miss the squared, you're going to probably lose 2 points because they won't give you that, and then you'll miss the answer point. So set it up blank, pi r squared. Now your boundaries are going to be x values since it's dx. So look at your picture. That's from where to where? 0 to 4. And inside of there, you're going to put the radius of your shape, which in this case is going to be upper graph minus lower graph. So look at, I'm going to just point to this. What is the upper graph? Square root of x. The lower graph is the axis, which is 0. So are you okay with me not writing it? It would be square root of x minus nothing. If you're really a purist, you can write square root of x minus 0, but it is just square root of x, the radius, upper minus lower. If it's a dy problem, instead of upper minus lower, it's going to be right minus left. We'll put the r and the l in there. All right, we're going to do this by hand. First thing we can do is the square root and the squared Yeah, cancel. It's going to literally just be x. And I'll be honest with you, the most common mistake people make is they forget to do an antiderivative, which is like the only calculus that there is. So please don't forget that step. What's your antiderivative of just plain old x? Yeah, 1/2 x squared such that 0 to 4. And we're going to do upper minus lower. So if you plug in 4 squared, 16, half of that, 8 times pi, so 8 pi. And if you plug in 0, it's going to just be 0. So your answer is 8 pi. Cool. Good. Let's do another one. Find the volume of the solid generated by revolution. We're going to revolve the region bounded by. All right, y equals x cubed. I'm going to put 0, 0, 1, 1, and -1, -1. It looks linear, but it's not. The cubic graph is like that wiggly thing. Do you know what I'm talking about? Yeah. Well, it would go off the grid, but what would the point for 2 be? 2 cubed is 8. Good. Okay, it would be like all the way up there. So something like this. Again, if you're writing with pen, wait to connect it because we're going to erase some of this. All right, the y-axis, that's just this. And the line y equals 3. So horizontal line at 3. This is your little shape. And we're going to erase the tails. So everything that's outside of that shape, just erase it. Because your picture gets super cluttered. And it's just easier to use your imagination and picture what's happening if you erase it. Perfect. Before I could even get there, but why is it dy? Because it is. Yeah, it says we're going around the y-axis, so it's going to be a dy problem. Ghost, you're already using my vocabulary. Ghost shape. To be clear, you take calculus again in college. Don't call it that. That is a Miss Cole thing. No one else is going to call it that. Okay. Well, I'm just letting you know. I don't want you to feel embarrassed. All right. So if you kind of flip it over, do you see how it looks like a Hershey Kiss? But it's solid the whole way through, like a Hershey Kiss, like it's filled with chocolate. I'm really bringing up that it's solid the whole way through because next time we're going to do the ones that do have holes in them. Get what I'm saying? Washers. All right, so set it up blank. Pi r squared dy. On the AP exam, typically it is a point for pi and the boundaries, a point for the stuff inside here, that includes the squared, and then like a point for getting your answer. So if you miss any piece of that, you're going to lose out. Now these need to be y values since it's dy. So look at your y-axis. It'll be where to where? Yep, 0 to 3, perfect. Now we're going to do right graph minus left graph. I can't really fit an L in there, but it's going to be right minus left. I need to take this equation and rearrange it so that the x is by itself. So what would we do to both sides there? Yeah, cube root of y equals x. Again, I have found over the years, I don't know why, but if I circle that, it goes better for everybody. So when we do right minus left, your right graph is that, and your left graph is the axis, which is 0. So you can write minus 0 if you want to, but it's just going to be cube root of y. We are going to do this one by hand, and it's not actually going to be that bad, I promise. Okay, I'm going to leave the pi integral 0 to 3. This would be y to the what? Just this inside part. I'm going to do it step by step. 1/3, but since there's a 2, it will be 2/3. There we go. When you do an antiderivative, you add 1 to the... Oh, go ahead. Oh, yeah, good. Sorry, I thought you were going to say something about this. Are you going to add 1 to the power? So that would be what? 5/3. Good. 1 would be 3/3. 3/3 is a whole 1, right? And then so in front of that, you have to put, oh, and pi, but 3/5, such that 0 to 3. We're going to do upper minus lower, but what would the lower one be? Yeah, but be careful, because is it always 0? No, okay, so just be careful with that. But I'm going to just plug in 3. It's going to be 3 pi over 5 times 3 to the 5/3, whatever that is. I don't know. That. No? No, because 3 to the 5th, that goes a little bit beyond what I would expect you to do without a calculator. And then the cube root of whatever that is, I don't know what that is. I know 3 to the 4th is 81. That's one that I kind of, 3 to the 5th, I think is 243. Yep. Okay. I only know that because I live in this room and do math problems, so I don't really expect that you guys know that. I'll leave it like that. All right, for this one, we're going to use the same shape for A and B. So after we draw it for A, we'll just copy it over for B. What is this graph going to look like? X squared. It's a parabola. What's been done to it? It's upside down, and it went up 4. Okay, so we're going to put a point at 0, 4. If you plug in 1, you're going to get 3. And if you plug in 2, you're going to get 0. So this is your reflected parabola. Now it also says the x-axis and the y-axis. So if you have a choice of the positive or the negative part of this, please choose the positive part. So we're going to use this right here and erase all of your tails. And so what I'm going to have you do is just draw that again down here before I do my ghost shape or anything else, because we're going to use that same shape for part B. Okay, this is going good. We're good on time here. All right, for A, we're going to make our ghost shape reflected over the x-axis. So that's going to be down here. And so you have to imagine this as 3-dimensional. I feel like if you turn it this way, it would look kind of like a pitcher's mound in baseball. Do you know what I'm talking about? Like it's circular, but it kind of is mounded up. Or do you ever see trees that have all that mulch around them? Imagine that, but without the tree in it. Do you know what I'm saying? It would be are you envisioning this with me? Are you coming with me? But it's round and it's 3-dimensional. Okay. So we're going to have pi r squared dx or dy? Dx. Cool. So boundaries would be where to where? 0 to 2. And it's going to be right graph minus, it's going to be upper minus lower. Okay, so your upper graph is this one. The lower graph is the axis, which is 0. So it's going to just be this 4 minus x squared. Now, I know you guys had a difficult algebra journey, okay? I'm going to explain to you how this works. I don't want to, because we don't have the time for the more in-depth conversations today. I don't want to hear, couldn't we also do this? No, I'm going to explain to you the only way that it works. Do you understand? We just don't have the time for it today, okay? So I'm sorry that I'm shutting that down, but this is the only way it's going to work. You have to take this 4 minus x squared and write it twice. This is a margin problem. Now, if you can hold that in your mind, then you don't necessarily need to write it, but I'm doing the problem in front of a whole group of people, so I'm trying to show you what's going to happen. Squared means it's a twin, you write it twice. So we're going to keep our pi integral 0 to 2, and we're going to multiply this all together. Basically, it's a bunch of distributing. 4 times 4, 16. Okay, now follow me on this. If you multiply these two, you would get negative 4x squared. If you multiply these two, you will also get negative 4x squared. So together, negative 8x squared. And then if you distribute these two together, the negatives will cancel. It will be positive x to the 4th. Yeah, we don't have a word. I kind of wish we did. Squared, cubed. Yeah, it is called a quartic. Yeah, but we don't have a word like cubed. You know what I mean? They gave up after 3. They gave up. Yeah, it's kind of like in geometry when you get past a decagon, we just called it an 11gon. They just gave up with naming them. Well, whatever. All right, we're going to do our antiderivative. So 16 will give you 16x. this would be minus, 8/3 x cubed. It would be 1/3 x cubed, but there's an 8 there. So 8/3 x cubed plus 1/5 x to the 5th. Cool. You add 1 to the power, put the reciprocal in front, such that 0 to 2. Once again, I don't want you to get the impression that if you plug in 0, it's always going to be 0. But in this case, it is going to be 0. So all we really need to do is plug in 2. 16 times 2 is 32. I'm not going to, simplify the whole way, but let's at least do a little bit of this. 2 cubed is 8, and then 8 times 8, 64 over 3, whatever that is, plus 2 to the 5th. If you don't just know that one, hold on, let me talk you through it because it is a good one to know. We're going to just count on our, don't talk over me. We're going to count on our fingers. 2, 4, 8, 16, 32. So 32 over 5, whatever that is. All right, now we're going to take that shape and revolve, revolution, spin it around the y-axis. So our ghost shape is over here now. Can anyone tell me what this looks like to them? Like half of a football? An umbrella that you could not stand under because it's solid literally the whole way through? Okay, cool. But we're envisioning it is the point, okay? First thing you're going to have to do is go and rearrange your equation so that it's x equals instead of y equals. So what would we have to do to this? We got a couple of steps here. Yes, subtract 4, y minus 4 equals, negative x squared. So you're going to divide everything by a negative. That's going to give you negative y plus 4 equals x squared. And then to get rid of the squared, square root. Now, typically you would have a plus or minus, but look it. Do you see how our original graph, we chose the positive side? It's just the positive square root of x. Do you remember the one, I know it's like a week ago, but do you remember the one we did where we had a positive square root and a negative square root? It was like the top half of the circle and the bottom half of the circle? Okay, anyway, we only have the positive part. So set it up blank. It's going to be pi r squared dy. Oh, I didn't circle it. Thank you. This one right here. I have found just from doing this for so long that when because people would solve it and then still plug in the wrong thing. And I just found if you circle it, people will remember. So we're going to do right graph minus left graph. But again, the left graph is the axis, so it's 0. So our right graph just is that square root of negative y plus 4. And what very convenient thing is going to happen? Yeah, those are going to cancel. Oh, what very important thing did I not put on there yet? Yeah, boundaries have to be y values. So 0 to 4. Don't forget to do an antiderivative. I get that once you get to that point, it feels like you did a lot of work already, so people skip the antiderivative. Understand completely why that happens. Please don't do that, okay? Antiderivative of negative y would be negative 1/2 y squared. And then, unfortunately, a lot of people will write plus 4x. It is plus 4y. If you ever look down and you have a combination of x's and y's, you have done goofed. Go fix something. Such that 0 to 4. And once again, all we really need to do is plug in 4. 4 squared. 16. Half of that's 8, but it is... All right, so we got negative 8 plus 16, which would be 8. 8 pi. Oh my gosh. Isn't that the same as, this one right here? Why did that happen? Well, it's the exact same object, just flipped sideways. Do you see what I'm saying? So that's why the volumes are the same. Okay, up until now, and this is why we get a calculator for these ones. Up until now, one of the upper minus lower or right minus left has been the axis, so it's been 0. Do you get what I've said for all of them? 0? Okay. These ones, it's not going to be. Okay. Let me get through setting this up, and then we'll open the computer and go to Desmos. So I do want you to practice typing it because it is an important skill. All right. We want x equals y squared. Is that a big red flag? Okay, it's going to be a parabola, but instead of right side up, it's going to be sideways. Okay, so we're going to get 0, 0, 1, 1, and then 4, 2, and negative 2. It's not a function, but we don't worry about the fact that their functions are not with this. We're just trying to find areas and volumes in this unit. And then we got x equals 4. So this is our vertical line, x equals 4. Here is our shape. I'm going to erase all of my tails. And then you're going to need to read, what is your axis of revolution? Yeah, not an axis. It's x equals 4. Okay, so what I'm going to do is dot that in. I think like we just erased it. Well, you'll be okay. Is it going to be dx or dy? Well, look it. Just watch me point to this. It's like I took the y-axis and just scooched it over a little bit. Do you see that? So it's going to be dy. If you want to go ahead and set it up, pi r squared dy. Again, it's like you took the y-axis and just moved it over. We're going to put our ghost shape on the other side of the axis of revolution. And so using your imagination, yeah, it would be the only way I would argue it's not like a football is, what is a football filled with? Air. I would say like, do you know like a chocolate egg you get at Easter time? How it's like solid the whole way through with chocolate? But it would look like a football. Only imagine a football that's completely filled with something, so you really couldn't throw it. It's filled with math. Okay.
But wouldn't it be more like a frisbee or like a discus?
No, it's like you have a shape that's like this and it spins the whole way around. So you're gonna end up with a 3-dimensional thing that's like this.
And a football is more like skinny.
Yeah, I'm not gonna argue the point. I just want you to imagine it, okay? Because I've taught this unit before and we get to the end of it and people are like, I have no idea what we did. And that makes me sad. Like, I want you to at least try to understand what happened. All right, so this is what we're using. I'm gonna circle it. We're gonna do right minus left. Are you looking? Because which side of this are we using? Well, it's the one you started with originally, and that's why I like to color it in. You see how this is the shaded in one? Okay, this is your right graph, which is what? 4, good. And this is your left graph, which is the y squared, okay? So inside of there, you're going to have 4 minus y squared. It's right minus left. And then what were our boundaries? They have to be y values. -2 to 2. Okay, so now I'm going to share my screen, and you guys can all bring up Desmos, and we're all just going to practice typing it to make sure we can all get the right answer. Typing it's an important skill too. And don't let me lose everybody, because I do have one more problem that we're going to do, okay? But I want everyone to practice. I got this, what did you get kind of thing. I think I typed, oh, I forgot a very important thing in mine. I was going to say that seemed a little small. I forgot the pi in front. I got 107.233. That's what you got? Now, on Delta Math, and I was just trying to check real quick. I don't know if they make you, yeah, nearest thousandth, and they make you round. So did this one round? No, 233. Okay, but just remember, they don't truncate, they round. So just be careful with that. All right, see one more. We are going to take this shape. It's a parabola flipped upside down and moved up 3. Okay, so go up 3, and don't let me lose everybody just because I let you have your computers out. Okay. Go up 3. What's another point we could plot? 1, 2. And so also -1, 2. And then probably one more. If you plug in 2, it'll be -1. Good job. 2 squared gives you 4, but it's negative. -4 plus 3 gives you -1. All right, and then y equals -1. And so this is our shape. Yeah, go.
How do we know what
Oh, the directions are going to tell you. Yeah, you'll either be allowed and it'll say do a decimal, or it'll be multiple choice and all your answers will be like 8 pi, or what were some of the answers we got, like 3 pi or 17 pi or whatever. Yeah, good. All right, so what are we revolving around? What is our axis of revolution? Yep, so we're going to dot in y equals -1. This one might be more football-ish looking. I don't know, is it a little skinnier? Or anyway, like a chocolate egg that's solid the whole way through. Or like a paperweight, I guess. Yeah.
You could just call it a blob of light.
A blob, yeah. I was trying to relate it to something in real life. An egg. It looks like an egg. That's what it looks like. All right, so pi r squared dx or dy? It's like you took the x-axis and just scooched it down a little bit. So yeah, dx. I want my boundaries to be x values, which would be -2 to 2. And then let me highlight on here. We want to do upper graph minus lower graph. So it's going to be a little tricky with the negatives, so stick with me. Which one is our upper graph? -x squared plus 3 minus, what is our lower graph? -1. So it is minus -1. I wrote it out that way so that everyone could see it, that it's upper minus lower, but minus and negative would cancel. And then you could add it to the 3. So like this, if that's how you want to type it in the calculator, because that's a little less to type. Personal preference, all right? But everybody go ahead and give it a shot. And I'll make sure. Oh, it's going to come out to the same thing though, isn't it? Because it's the same thing except flipped the other way. It's the exact same shape. I thought it looked a little skinnier, but it's not. It's the exact same thing because now I see that the equation matches. It's just this one's an X and that one's a Y.